All right, SpongeBob challenge number 32. SpongeBob challenge number 32. We're going to be adding rationals together. Now, our first experience with adding rationals was basically fractions. Trying to add things like 1/2 plus 1/3. And the key to that was making a common denominator. So we would create a new denominator by using what was already there. We said, well, I also need a 3 here. So now you have a 2 and a 3 that has something for both denominators, and a 2 and a 3 here that has something for both denominators. They already had the 1s there. Then you look at what it was added. This originally was a 2, now it's a 2 and a 3. 3 is additional, so whatever is additional in the denominator is additional in the numerator. Whatever is additional here in the denominator, here is a 2, you add to the numerator. Once that's done, you can then multiply the numerators together, and you can get 3 and a 2. Now, typically we multiply the denominators, but let's say we didn't. Just kept it 2 times 3, 2 times 3. We can still add the numerators, which will give us 5 all over 2 times 3. So this is basically what we're going to do with the rational functions. Let's start here. Let's find out what we need for a new common denominator. Okay, 4 is the numerator, 1 is the numerator. Now, I have x to the 4th, x to the 2nd. Okay, who has the greatest amount, or the least amount for everybody? Well, that's common. And it would be the higher number here, the x to the 4th. So I'm going to put x to the 4th in both cases. So x to the 4th here, and x to the 4th there. The higher of the two there. We have an x plus 3 here and x plus 3 here. There's 2 of them there, there's 5 of them there. We're going to put the higher of the 2 in both cases here and here. So x plus 3 to the 5th here. X plus 3 to the 5th, and then x plus 3 to the 5th. All right. Now that the denominators are matching, we're going to go ahead and find out what we need to add to the numerators. Okay, here we have x to the 4th, x to the 4th, so there's nothing extra there. Here we have x plus 3 to the 2nd, x plus 3 to the 5th. So there's an extra x plus 3, 3 of them actually in the denominator here, so we're going to add 3 of them here. X plus 3 to the 3rd power, and that makes up for the 3 that we added here. Let's go over here. Next, we have an x to the 2nd power, x to the 4th power. So there are additional 2x squares that have been from here to here. So we're going to put an additional x squared here to make up for the ones that we added here. Here we have 3x plus 4, I'm sorry, x plus 3 to the 5th, x plus 3 to the 5th. So no extra x plus 3s have been included, so that's it. Now from here, we'll create one denominator, x to the 4th, x plus 3, all to the 5th. Now, these two are already multiplying, so, and notice that we're not going to multiply this because this is the 3rd power. If this is to the 1st power, I will distribute. Because it's the 3rd power, I can't distribute the 4. So it just stays this way. Plus 1 times x squared is x squared. And we're finished. That's it. Okay, let's take a look at number 2. All right, we're going to create new denominators that have something for everybody. And let's put 3 here and 2 there. And we're going to begin the process. Here we have x, here we have x to the 3rd. The higher of these two will be x to the 3rd. So we're going to put x to the 3rd on both of these. Okay. Next, we have x minus 5s. There's x minus 5s here. There's x minus 5s there. Let's see. We have 4 of them here, 5 of them there. We're going to use the 5 here on both of them. So x minus 5 here, 5th, and an x minus 5 here, is the 5th. Okay. And now we have common denominators. Now let's find out what was extra in the denominator so we can put it in the numerator. So here we have an x to the 1st power, here we have an x to the 3rd power. So what we have here is an actual 2 more x's, or should I say an x squared has been added from here to here. So let's put an x squared here to make a difference. Next, we have the x minus 5, there are 4 of them here, and x minus 5, there's 5 of them here. So there's an additional x minus 5 in the denominator here. So I'm going to put an additional x minus 5 here, there. Okay, so that makes a third thing. Okay, let's compare. We have an x to the third, x to the third. There's nothing different. So there's no more x to the thirds here. We have the x minus 5 here. We got 5 of them. And down here, we have 5 of the x minus 5s. So there's nothing additional. Okay, next. Okay, we're going to make one denominator of x to the third, x minus 5 to the fifth. Now, notice that the power here is 1 as opposed to the 3. Any power is higher than 1, we don't really spend time right now multiplying. But if it is to the first power, we can distribute. So the 3x squared times the x gives us 3x to the third power. And the 3x squared times the negative 5 gives us a negative 15x to the second power. And then plus the 2 over here. And we're done.
Sensei.
Okay, let's take a look at number 3. We have 2 over x plus 2 to the fourth, plus 1 over x to the fourth, x plus 2 to the fifth power. Put number 4 up here, just know where we're going. 5 here, x to the 4, 7. Should I look at 7? Yeah, it should be. X equals 3 minus over x squared. Okay, so starting here, I want to create new denominators for both of these. And let's look at x's. Here I have an x, here I have an x to the fourth. The higher one is definitely the x to the fourth. So we're going to put that in both places. So the higher goes in both places. X to the fourth, x to the fourth. Okay. We also have x plus 2s. We have x plus 2 here, we got 4 of them. We have x plus 2 over there, we got 5 of them. The higher number is 5, so we can put 5 on both sides. So x plus 2 to the fifth, x plus 2 to the fifth. And I forgot to put my 2 and my 1 here. So put those up there real quick. All right, let's see the difference between the numerator and denominator. Here I have an x, here I have an x to the fourth. So I can see that additional 3 x's were added to the denominator here. So I'm going to put an additional 3 x's here in the numerator. Because again, going from x to the fourth means I added 3 x's to go from here to here. So whatever you add to the denominator, we add to the numerator. Here, I see that I had 2x to the fourth, and I had 2x to the fifth here. So that's an extra x plus 2. That's an extra x plus 2. So let's put an extra x plus 2 here. All right, so that fills in everything. All right, checking out this. I have an x to the fourth, so I didn't add any more x to the fourth, so we can ignore that. I have a 2x plus 5, x plus 2, I have 5 of them. I also have x plus 2, I got 5 of them there, so nothing additional was added, so we don't have to add anything to the numerator. Okay, good. All right, let's create one big denominator. X to the fourth, x plus 2, all to the fifth. Okay, the power here is 1, which means I can distribute this. So this can go here. 2x to the third times x is 2x to the fourth. And 2x to the third times the 2 is 4x to the third. Then plus the 1. And that's finished. Okay, let's go over here. Okay, now we're dealing with a minus sign. I'll show you how to handle that. So let's create 2 fractions here, and 5 and 3. And we'll start looking at the x's. I have 4 of them over here, I have 2 of them over there. Well, the higher of the 2 will be the x to the fourth. So I'm going to put x to the fourth here and here in both spots. So here's the x to the fourth, and there's the other x to the fourth. Again, I got this from the higher power here. Now, we have x plus 3s here and x plus 3s there. Okay, I got 7 of them here, 5 of them there. Who has the most? The 7. So we're going to put 7 in both spots. Okay, so x plus 3, let's put 7 there. X plus 3, let's put 7 of them there. Okay, and that gives us common denominators. All right, let's see what's extra. Here, my denominator had x to the fourth. Here, my denominator x to the fourth, so there's nothing extra there. Here, the x plus 3s, I got 7 of them there. I got 7 of them here, so there's nothing extra. So I don't need to do anything. Here, I have x squares. Here, I have x to the fourth. This means I put an additional 2 x's here in the denominator. So let's put an additional x squared in the numerator. The x plus 3s. I see I got 5 of them there. Now I have 7. That means I added another 2 of them. So let's multiply here by the extra 2. All right. Now, let's look at what we have here. We have one big denominator, x to the fourth, x plus 3, all to the 7th power. This little square right here prevents us from distributing. So we won't distribute this at all. So we'll just put everything here, 5, then the negative, the 3, x squared, and the x plus 3, all to the 2nd power. Again, no distributing. We just leave it as is and we're finished. Oh. Number 5.
There you go. There's my answer.
Okay. All right. Number 5. Again, we have different denominators, so we're going to create the same denominator. 3 and 4 here. And let's see what we got here. We have x to the 2nd power, x to the 3rd power, and the higher of the two is x to the 3rd power. So we put x to the 3rd power here and here. X to the 3rd, x to the 3rd. Then we'll look at the x minus 7s. I got 2 of them there and 3 of them there. The higher of the two is the x minus 7 to the 3rd. So we'll put this one in both spots. X minus 7 to the 3rd, x minus 7 to the 3rd. Okay. Now let's see if there's any differences. Okay, I have 2 x's here, but I got 3 there. So obviously I added 1 x here. So let's add 1 x here as well. The x minus 7, I got 2 of them there and 3 of them there. So obviously I added 1 more here to get 3. So let's add the x minus 7 here and 1 more there. Okay, over here. X cubed, no more x's were added. X minus 7, I have 3 of them there, 3 of them there. There's nothing more added, so that doesn't change. So let's put one big denominator here. X to the 3rd power, x minus 7, all to the 3rd power. Okay, now notice here, this is x minus 7 to the 1st power, so we can distribute. So I get 3x multiplied here, so 3x times x is 3x to the 2nd power. And 3x times a negative 7 is negative 21x. Then on my minus sign here, and then the 4. We're done. Okay. And one more, number 6. Number 6 is still on the computer, so I'm going to look here. I think I know the essence of number 6. So 4 and 2. And the numbers are going to be plus 2, x plus 2, x plus 2. And the powers are 5, 2, 5, 2, 3. 5, 2, and 3. Okay, so here we go. Let's create new fractions here, still using the formula 2. And I have x to the 5th, x to the 3rd. Who's the bigger one? Hey, it's the x to the 5th. So we're going to put x to the 5th here and here. X to the 5th, x to the 5th. Okay, I have x plus 2's here and x plus 2's there. I have 2 of them there and 1 of them there. We're going to use x plus 2, the 2 of them here. So x plus 2 squared, x plus 2 and squared. All right, now we got common denominators. Let's go and find out what we need to add to the numerators. Here I have x to the 5th, here x to the 5th, so no more x's were added here. Here I have the x plus 2s. I got 2 of them there. I got 2 of them there. So I don't need to add anymore. Here, I got x to the third here, and x to the fifth. Added 2 more x's. So let's put 2 more x's there. And here I have x plus 2. I just got 1 of them. And here I got 2 of them. So obviously I added 1 more x plus 2. So let me put 1 more x plus 2 in the numerator. Okay, now let's create one denominator. X to the fifth, x plus 2 to the second. Okay, so the 4 was first. And what I have here is I want to distribute my negative and the 2x squared here. So let's put let's actually put the negative here so we can take out everything together at one time. So negative 2x squared times the x gives me negative 2x to the third power. And negative 2x squared times a positive 2 gives me negative 4x to the second power. Now, order. We like our highest powers first and all the way down to our lowest. This is our highest power, the next one, and this doesn't have any powers at all. It doesn't have any x's. So I'm going to write this as negative 2x to the third, it's going to be first. Then the negative 4x to the second is next, and then the 4 here. And that's everything over x to the fifth, x plus 2, all to the second power.